I can show you the variation in the lines, that is green line, blue line, and a red line when I tilt the accelerometer. Check here. Accelerometer, when I tilt it upper, up, down, forward, backward, straight. So you can see the image graph on the you can see the image graph on the serial plot. In this experiment, I am interfacing triple axis accelerometer with the Arduino Uno board. And in the previous video, I have interfaced triple axis magnetometer with the Arduino Uno board. And the triple axis magnetometer has 5 pins. Out of 5, I used only 4 pins: VCC, ground, and SCL and SDA. And in this accelerometer, it is having 8 pins: VCC, ground, SCL, SDA, X, XDA, XCL, AD0, and INT. Out of 8 pins, I am using only 4 pins: VCC, ground, SCL, and SDA, same as that of previous video, that is triple axis magnetometer. The VCC is connected to 5 volts pin on the Arduino Uno board, and the second one is ground, blue color wire. It is connected to ground pin on the Arduino Uno board. Third is SCL, serial clock. It is connected to A5 pin on the Arduino Uno board. And the last one is SDA, serial data. It is connected to A4 pin on the Arduino Uno board. So this is about the connection. What is accelerometer? The accelerometer, it measures the acceleration. What is acceleration? It is the rate of change of velocity, and since it is triple axis accelerometer, it measures the rate of change of velocity along x-axis, y-axis, and z-axis. So it detects the changes in speed, and it detects the changes in the direction. For that purpose, accelerometer is used. In the previous video, I used magnetometer. What is magnetometer? It is used to measure the magnetic field strength and the direction along x-axis, y-axis, and z-axis. It detects the magnetic north. Which one? That is magnetometer. And it is commonly used to determine the heading or the compass direction. That is the difference between accelerometer and a magnetometer. And now uh, I have done the connection, and I uploaded the code, and let us check the values it is giving in a serial monitor. You can see the values displayed in a serial monitor, that is x equal to -104 and y is equal to -77 and z is equal to, it is keep on changing. The z value and y value are changing. So what these data represents? The accelerometer measures the acceleration along the 3 axes: x, y, and z. Each line in the data represents the sensor's position or sensor motion at a particular moment. The values what you are seeing, ACCL XLX equal to -104.20, it indicates the force of acceleration along each axis. So that is the force of acceleration. It is measured in meter per second. Okay. Then the x value shows the force acting horizontally along x-axis. And it is giving me the negative value. It means that the and y-axis value, this is nothing but the force along the y-axis. So the negative value, it indicates that the force is in the negative y direction. And last one, Z value. It measures the force along the vertical axis. Okay, so if this value is close to 0, sometimes it is becoming less and sometimes it is becoming more. So it means that positive or negative, the z axis value changes going around from minus 84 to it is going up to 0 also. So this means that the sensor orientation along z-axis is changing slightly because of small tilt or a movement. So if the z value is high positive or if the z value is high negative, then its orientation in the sensor is oriented in a space. That is, sensor might be vertical. It might be vertical. Okay, then now I am tilting the sensor. See the value of z and observe the value of y. I am giving the force in y axis. The y value is also changing and z value is changing. Okay, so in this way you can measure the value of x-axis, y-axis and z-axis. Applications of this accelerometer are they can be used to detect the tilt angle of the device. If you attach this accelerometer to some device, if the device is tilted like this, so you can measure the tilt angle using this accelerometer. And you can detect the movement or sudden acceleration if the object is moving very fast or sudden fall. So that also you can detect with the help of this accelerometer. And you can monitor the vibrations in the machine. If you attach this to some machine, if the machine is vibrating, so you can get the change in values in x and y direction. That also you can monitor. You can monitor the vibrations in the machine or on the surfaces. And where we can use it can be used to detect if the device is falling. If you attach this sensor to one device, if the device is falling from the top to some other place, if it is falling, and then it is used in devices to protect the data storage or components during the impact. So these are the applications of accelerometer. The accelerometer measures the acceleration along x-axis, y-axis and z-axis. So it can be used to determine the orientation, motion or tilt, anything you can measure with the help of accelerometer. Now I am holding accelerometer in this position and it is giving me the values of x, y and z are x positive, y negative and z positive. You can check the values in a serial monitor. Now I will tilt the accelerometer. You just check the values. The values are getting changed. X, y, z all became positive. I will tilt the accelerometer in this direction. So x become negative, y positive and z negative. Downward, all are positive. This direction, y negative. So in this way, the values are getting changed. Now I'll go to tools. I'll click on serial plotter. So you get the lines here, green line, blue line and yellow line. So you just check here. See, when I tilt this, the line positions are getting changed. You can check here. I am tilting this side, left, right, bottom, top, and I'll hold this straight. Again the lines are coming straight. So in this way, the accelerometer is detecting the force applied on x-axis, y-axis and z-axis. This red line that is on x-axis, red line shows the acceleration or tilt detected along the x-axis. Changes here reflect the movements or tilt forward or backward. Red line, see, forward or backward. The tilt for forward or backward relative to the sensor orientation. That red line. Next is green line above one. The green line represents acceleration or tilt along the y-axis. So if you make the movement left, see, left, right, so left, right relative to the sensor orientation. And the z-axis, that is blue line, bottom one. So this line represents the acceleration along the z-axis. So that is when sensor is moving up, see, up or down, up or down. So rotation on its vertical axis. So this line is represented by blue line. So if I hold the sensor in a horizontal and stationary motion, all the lines will become stationary in horizontal direction. So in this way, you can detect the three lines in the serial plotter. They represents the real-time values of acceleration. Real-time values of acceleration along x-axis, y-axis and z-axis of the accelerometer. Today I am going to show you how to interface accelerometer, that is MPU6050 accelerometer with Arduino IDE board, and how to plot the graph or in a serial plotter. So this is the image of MPU6050 accelerator. It has got 8 pins: VCC, ground, serial clock, serial data, and XDA, XCL, AD0 and int. So out of 8, I am using only 4 pins: VCC to 5 volts pin on Arduino IDE board. You can connect it to 3.3 volts also, and ground to ground pin of Arduino IDE board, and SCL to A5 pin of Arduino IDE board, and SDA to A4 pin on the Arduino IDE board. So connection is very simple. Then I have written 2 code here. One code just to display the values of force applied on x-axis, y-axis and z-axis. And that is the rate of change of velocity in x-axis, y-axis and z-axis. And the second code to plot this in a serial plotter. So 2 codes, whichever you want, you copy this and paste it in Arduino IDE software. And in first code, this code one, it is easier setup with Adafruit. Adafruit MPU6050, and for better data structuring, and it is suitable for serial monitor. So serial monitor, it is good. And it is highly customizable for a specific application. But the second code, this code, you can make use of direct access with the MPU6050 library and the raw data processing, and it is suitable for real plotting on the Arduino serial plotter due to its simple output or space operated output. So these two are the difference between code 1 and code 2. Both are used to measure the acceleration only. The code difference I am telling you. And the code 1, this code 1, here calls MPU, here calls MPU dot get event ampersand A, ampersand G and ampersand temperature to retrieve the structured sensor event. So the event which includes the accelerometer, or it may be gyroscope, or it may be temperature data in a single functional call. So in code 2, it reads the accelerometer data using Excel gyro. This one, Excel gyro function. So Excel gyro, that is using Excel gyro dot get here it is Excel gyro dot get acceleration ampersand AX ampersand AY and ampersand AZ. So this then it manually scales it to the units of G by dividing 16,384. This is very much necessary because the MPU6050 library provides raw 16-bit integer, and scaling factors must be applied manually. That's why we are dividing this by 16,384. So only this is the difference. And first, let us copy the code one. Let us copy the code one and paste it in Arduino IDE software. I'll go to Arduino IDE software now. I'll paste it. So I copied the entire code and I pasted here. Now I'll choose the COM port to which the Arduino Uno board is connected and Arduino Uno board. And now I'll hit the upload button. I have already uploaded this code, and I have set the serial baud rate as 9600 and choose this baud rate. Now it is displaying this value. It is giving the values on x-axis, y-axis, and a z-axis. Now from this I can't draw the serial plotter. If you go here, tools and serial plotter, we will not get any lines or waveform here, chart here. So why we don't get this? Because the data format what I have written in this code one, it is not suitable for serial plotter. So for that purpose, I am not getting any graph here. I'll close this. So I'll copy the second code now. Pause for a few seconds. I'll go and copy the second code. Copied the second code in another a sketch, and hash include wire.h, and directly there is no add of fruit added here. Direct MPU6050 library file. So now I'll select the board and port and I'll hit the upload button. Go to serial monitor. Now I am getting the values. There is no x equal to y equal to z equal to. That we can't do while using the serial plotter. So now you go to tools and click on serial plotter. So I am getting the three lines, green, red, and a blue line. In this way, you can check both the codes. So the first code just it displays the XYZ values in a serial monitor. The second code, it displays the XYZ values without x equal to y equal to z equal to, just the values it will display in serial monitor, and the graph in the serial plotter. So this is all about interfacing of triple axis accelerometer with Arduino IDE. I can show you the variation in the lines, that is a green line, blue line, and a red line when I tilt the accelerometer. Check here, accelerometer, when I tilt it upward, up, down, forward, backward, straight. So you can see the image graph on the you can see the image graph on the serial plotter.